Hi, Year 9. This is meant to recap what we talked about in 4A on exploring Pythagoras' theorem, and then it's also meant to introduce you to 4B and C. So let's go ahead and take a look at all of what we've talked about over the last few days. So just when you look at a triangle, we want to make sure that if there is a little square in the corner, it is referring to a right triangle. Okay, so we cannot assume that a triangle is a 90-degree right triangle unless it has that little square in the corner. The other piece is that a lot of times we call right triangles by their legs or their side lengths. So we'll call these two sides that make the 90-degree angle the legs. So this is a leg, this is leg A, and then we also have leg B. So the two legs make the 90-degree angle. And then there's one side that is not a leg, and that is across from the 90-degree angle, and that is your hypotenuse. Hypotenuse is also known as the longest side, which is what we figured out when we measured some of the right triangles in class, okay? But our hypotenuse is the longest side, and a lot of times we use the letter C to represent your hypotenuse, especially in Pythagoras' theorem. So after we measured a bunch of right triangles, we realized that there is a relationship between them. And the relationship is that if you take one side and square it, and you add it to the other side and square it, then you wind up with a third side, which is your hypotenuse, and that is squared. So this C value always has to be the hypotenuse. The other two values, A and B, are the two legs that make your 90-degree angle. Okay? So today in class we were just going over what is Pythagoras' theorem and why is it true. And we want to make sure we have a common knowledge when we talk about Pythagoras' theorem, what part of the triangle we're looking at and what type of triangle we're looking at. So we have to be talking about a right triangle. So let's go ahead and take a look at how Pythagoras' theorem gets to be applied in two different situations. So the first situation is when you're asked to find the hypotenuse. That means that our hypotenuse must not be given to us. So my hypotenuse essentially is your x. We don't know what it is, okay? It is our unknown. The other thing we have to make sure we know is that we have to make sure we're actually looking at a 90-degree right triangle. So always check that there's a mark to tell you that there is a 90-degree angle in the corner of one of the corners. So I have a 90-degree angle. I don't know what my hypotenuse is, but let's say you're told that one of the legs is 4 centimeters and the other leg is 3 centimeters. In order for me to find the hypotenuse, I need to use Pythagoras' theorem. So the first thing that I would like to see you guys show when you're working is that you've identified that if it's a right triangle and I'm trying to find one of the missing sides of my right triangle, I need to use Pythagoras' theorem. So the first thing I'm going to write down is Pythagoras' theorem. Second, I need to figure out what is my A, my B, and my C value according to this picture. So in this picture, my A and my B can be the 3 and the 4, and it doesn't matter which is which. So I could choose 3 to be A, and I could choose 4 to be B, or I could choose 3 to be B and 4 to be A. It's up to you. As long as your A and B are the two legs of my triangle, it doesn't matter which one is which. So I'm going to go ahead and say that 3 is A, so 3 squared, plus my B is 4 squared, equals my unknown, which is C squared. Now in my picture, C is labeled as X. So I'm going to go ahead and put X in so that my work matches my diagram. We can go ahead and simplify this because we know 3 squared is 9, 4 squared is 16, and then I can go ahead and add 9 and 16 makes 25. So now how do I actually isolate my X? If I have an X squared, then that means something squared equals 25. So the opposite of squaring is to square root. If I square root both sides, the square and the square root symbol cancel each other out, and I'm just left with X. And the square root of 25 is 5. All right? So technically, I want to be thinking of it as positive or negative 5. However, when you're talking about the length of a triangle, I want to just take positive 5. So technically, I should get both positive and negative 5 as my values for x. But we're talking about length, and length can't be negative. So I'm going to go ahead and use just positive 5. All right? But this working would be required for an equation like this one, where I have to solve using Pythagoras' theorem. Let's look at another example where we're asked to solve for the hypotenuse, or find the length of the hypotenuse. Again, I realize that I have a 90-degree angle, so I know I'm using a right triangle, and I'm talking about the side lengths. So anytime I'm talking about the side lengths, I can think of this side as A, this side is B, and then my C is what I need to find. So the first thing I should write down in my working is A squared plus B squared equals C squared. And I can substitute 24 squared plus 7 squared equals my hypotenuse squared. And then I can also go ahead and simplify that again. So 24 squared, if that's something I'm not 100% sure of, I can always grab my calculator and I can put in 24 squared. So on this calculator, I'm going to have to use 24 times 24. All right, 576. So I can go ahead back to my working, and I can put in 576 plus 49 equals C squared. All right, so now I have 625 is equal to C squared. And remember, to get rid of the square, we're going to do the opposite, which is to square root. And I should get C is equal to plus or minus 25. But remember, we're talking about the length of the sides of a triangle, so I'm always going to go with the positive 25. So if I look back at my triangle, this side should be the longest, and if it's 25, it is the longest. And one more example, if I have, again, another right triangle, one side is 5, and then I see these little hash marks. So this hash mark means that these two sides are equivalent. So that means I can also safely say that the other side is also 5. So both of the legs are 5. I still don't know what my hypotenuse is. So I'm going to go through the exact same steps. I'm going to start with writing down my Pythagoras theorem. I'm going to identify, let's say this one is A and this side is B. Doesn't matter in this one because they're both 5. So 5 squared plus 5 squared equals my hypotenuse squared. That is 25 plus 25 equals C squared. So 50 equals C squared. Now this one is not going to work out to a perfect square. So if I take the square root, I'm going to get plus and minus square root of 50. So again, if I'm not sure what that is, and I go to my calculator, and I put in 50 square rooted, I get a decimal. So this is why we were practicing writing down decimals to at least 2 decimal places. If I round this decimal off, the square root is 7.07. So let's go ahead and take that to 2 decimal places, and we'll approximate our answer as 7.07. So I'm going to change this equal sign to approximate 7.07. And again, I always want positive. So C is going to be approximately positive 7.07 as my final answer. So when I go back to my picture, I can say this is 7.07. It's the longest side. Makes sense that it winds up being about that long. Last but not least, we have another scenario when you guys are asked to find the length of a leg, also known as the shorter side. So for example, if you identify that this is a right triangle, which means I can use Pythagoras' theorem to talk about the side lengths. And let's say I'm told that my hypotenuse is 5, and one of the legs is 4, but I don't know what the other leg is. So I need to find one of the legs. I'm going to again set up Pythagoras' theorem and substitute in the values that I know. However, this time I don't know A, so I'm going to leave that as A squared. And then I do know that B is going to be 4 squared, so I'll call that side B. And then I know that my hypotenuse is 5 squared. Okay? So I've identified all the parts of this equation that I know. So let's go ahead and simplify. A squared plus 16 equals 25. The reason why we spent the last chapter solving equations is because we're going to have to realize that in order for me to isolate A, I need to subtract 16. So if I subtract 16 from both sides of the equation, I end up with A squared is equal to 9. Now I have an equation that I can solve by taking the square root, and I can say that A is equal to plus or minus 3. And then again, remember, I want to just take the positive, so A is equal to 3. All right? Go ahead and try this last example on your own. Set up Pythagoras' theorem and see what you get as your answer. And we'll check it in class when I see you guys next time. All right? Have a good night.